In this problem, we're being asked to evaluate a Riemann sum. And a Riemann sum is a way to estimate the area under a curve by breaking it up into rectangles. And usually this is on some interval. So in this case, we have the curve here given by this function, g of x, is the square root of 8 minus 2x. And then we have an interval from -4 to 4. So I made a picture of this graph so we could kind of think about it. You don't need to do that to solve this problem, but I wanted you to see what it looks like. So we're going to take from -4 to 4. So we're finding the area under the curve there to the right of that line I just drew. Now, it'll give you some instructions about how to do that. It wants it divided into 4 subintervals of equal length, and then evaluate at the left endpoint. Sometimes you'll be asked for a left endpoint, sometimes you'll be asked for a right endpoint, and that's going to change the value of your Riemann sum, so be paying attention to that. So let's go ahead and divide this into 4 subintervals of equal length. From -4 to +4 is a distance of 8, so my subintervals are going to be 2. So from -4 to -2, so we'd have something going on here, and then to 0, and then to 2, and my last would be right there. Okay, so 1, 2, 3, 4 subintervals of equal length, and it says the function is evaluated at the left endpoint. So our first endpoint here, the left endpoint, is the one that's going to make the rectangle. So our first rectangle looks like that. Our second rectangle looks like that. Our third looks like that. And our fourth looks like that. So you can see in this case, a left endpoint evaluation is going to overestimate the area under here, but that's okay. If we did the right endpoint, it would underestimate it. And so if you do both, you can know that the area is somewhere in between those. But for this problem, all we have to do is add up the areas of all of these rectangles and give that number. I think the easiest way to do that is setting up a quick spreadsheet. The width, I mean, the area of a rectangle is length times width or height times width. The width of all of these is 2, so that's easy enough. The height of this thing is f of x. It's the value of this function, the square root of 8 minus 2x. So let's go ahead and pop that into a quick spreadsheet. So what I want to do is list my endpoints first of all, because that's where I'm going to evaluate the function. That's the x I'm putting in, the f of x. So we start at -4, and then we have -2, and then 0, and then 2. And then that endpoint, the top of the rectangle, the height of the rectangle, is going to be our function evaluated at these points. So I'm going to put in an equal sign, and then the square root function is sqrt, and then we've got 8 minus 2 times x. The x is going to be this cell. All right, so we're going to enter that. It's suggesting an autofill. I'm going to accept that, and there it is. This all makes sense. It is the value 4. We can see that from the graph right there. It's at 4 at -4, and if you think about that, -4 putting in for x times a -2 is going to be 8. So 8 plus 8 is 16. Yeah, that's the square root of that is 4. So that all makes sense. We're doing that right. Okay, so we've got the heights of all these rectangles. The widths are all 2. And then I can just put in a formula for the area, which equals length or height times width. And it gives me an autofill suggestion too. So those are the areas of all the individual rectangles. Let's sum those up to get our Riemann sum. So equals SUM parentheses and select all that and close the parentheses. And we get 24.5851. It's asking, actually, in the problem, it asks us to round the final answer to 4 decimal places. So they're asking for a lot of precision there. So that's 4 decimal places, that 0.5851. Well, that is how to do a Riemann sum. If you wanted to do a right-handed, all you'd have to do, now I've got this all set up, all I'd have to do is change the endpoints and start with -2, 0, 2, and 4, and I'd have the right-hand sum. All right, hope that helps.